All right, let's dive into one of the biggest, most mind-bending questions humanity has ever asked. What's behind the universe? Seriously, this is a journey to the very edge of what we know, and maybe even what we can know. Let's get into it. So, what's behind the universe? It sounds so simple, doesn't it? But what are we really asking here? Are we looking for some hidden room just past the edge of space? Or is the answer something way, way more profound? You know, this single question has been the engine for some of the greatest scientific quests in all of human history. Okay, so first things first, we've got to get on the same page. When a physicist talks about what's behind the universe, they're not thinking about a location. It's not about geography or finding some cosmic back door. And this right here, this is the big pivot, the real aha moment. We have to shift our thinking from the where, a physical spot on a map, and start thinking about the how and the why. We're not looking for an address. We're trying to figure out the fundamental rules that made everything, well, everything. This is what they're really after, the underlying principles. It's like finding the universe's source code, the ultimate rulebook of reality. We're talking about the origin story, the mechanisms, the absolute bedrock laws that fired up space, time, and matter to begin with. That's what behind the universe really means to a scientist. Right, so just to nail this down, we're not cosmic explorers looking for an edge to peek over. We're more like cosmic detectives, hunting for clues about how this whole reality got started. It's all about the origin. Okay, so if the big question is about the origin story, what do we actually know? Let's trace our cosmic history back, as far as the evidence will take us. The story science tells is just epic. It starts with this unbelievably hot, super dense state, a whole universe packed into a space smaller than an atom. From that one point, it just explodes outwards, expanding and cooling down. That allowed energy to turn into matter, which then clumped together to form the first stars, then galaxies, and, well, eventually us. And today, here we are, living in this massive cosmos that plays by a set of physical rules we can actually measure. But, and this is a huge but, this is where our map just ends. Our science, our laws of physics, they're fantastic at explaining what happened after that hot, dense state. But they totally break down when we try to ask, okay, but what happened a second before that? Or what caused it in the first place? That is the hard boundary of our knowledge. So, to step past that boundary, well, that's when we enter the wild, fascinating world of pure theory. Now, these aren't just random guesses. These are ideas built on solid physics, trying to get a little peek into that ultimate unknown. So, theory number one, and this is a wild one. What if our entire universe just popped into existence from literally nothing? Now, this sounds completely crazy, I know, but it's actually grounded in the seriously weird rules of the quantum world. See, down at that level, nothing isn't really empty. It's more like a fizzing, bubbling sea of potential. Energy can just spontaneously appear and disappear. Some physicists think our entire universe might just be a quantum fluctuation that got way out of hand, a cosmic spark in some deeper quantum reality that just happened to ignite everything. Okay, so that's one idea. But what if our universe isn't a solo act? What if it's not a one-time thing? A second major theory suggests our cosmic home is just one in a crowd. This, my friends, is the famous multiverse idea. Picture a kind of cosmic foam, where new bubble universes are constantly inflating into existence. And get this, each bubble could have its own completely different set of physical laws. In that scenario, our universe, with its specific rules that just happen to allow for stars and life, isn't special at all. We're just one lucky roll of the cosmic dice out of an infinite number of possibilities. Now, hold on. As cool as all this sounds, we have to pump the brakes for a second. It is absolutely crucial to remember that these are frontier ideas. They're mind-blowing, for sure, but they are incredibly difficult, maybe even impossible, for us to test with the technology we have today. Think of them as guideposts for where to look next, not as established facts. So you might be thinking, okay, if we can't prove any of this, what's the point? Why even bother asking? And you know what? That is a fantastic question. Because here's the thing. The quest is what matters. The act of searching is this powerful engine for discovery. It's not just about getting to the destination. Even when they're tackling these massive questions, scientists have a rigorous toolkit they have to use. They observe the cosmos for every tiny clue. They use math, which is really the language of the universe. And they use logic to build theories that you hope can one day actually be tested. And that's really the heart of it, isn't it? Asking what's behind the universe forces us to get smarter,
to build better tools, to push the absolute limits of human knowledge. The question itself is the fuel. It's what drives our understanding of the whole cosmos forward, step by step.
So I'll leave you with a final thought to chew on. Maybe the goal of this whole grand adventure isn't to find one single, neat and tidy answer. Maybe the real discovery is learning how to ask better, sharper, deeper questions. In the end, perhaps the universe's greatest secret isn't an answer at all, but the endless curiosity it sparks inside of us.